Hello everyone, welcome back to my daily coding series. Today is day 73. So I only have like 20-ish minutes before I have to go, so I'm going to look at an easy problem today. So hopefully this will be a quick video. So this is contains duplicate 2, so I just kind of clicked on it pretty randomly. So alright, let's take a look. So we have an array of integers nums and an integer k. And we want to return true if there are two distinct indices, I and j, such that nums of I equals nums of j. Okay, so basically, if there's two different indices with the same value, so if there's basically the same value, and the absolute value of I and j is less than k. Okay, so basically we're saying, is there a duplicate within k spaces? So in the first example, 1, 2, 3, 1, k equals 3. So we're checking, is there a duplicate in 1, 2, 3, and is there a duplicate in 3, 2, 1? Or sorry, 2, 3, 1. So we see there's no duplicate here, and there's no duplicate here. So this should be false. Oh. So it's going to be... So I think it's plus 1. I think I'm off by 1 because absolute value of I minus j, so that would be 0 minus 3 is less than or equal to 3. So I think it's this number plus 1 is your window size. So actually you're looking at just the window like this. Okay, and then the second example, we have 1, 0, 1, 1. K equals 1. So that means that the difference of index has to be 1 or 0. So that's 0, 1, sorry, 1, 0, 0, 1, and 1, 1. So is there a duplicate in any of them? Yes, this last grouping here has a duplicate, so the output's true. And then if we look at 1, 2, 3, 1, 2, 3, with k equals 2, then we'd have 1, 2, 3 is one window, 2, 3, 1 is another, 3, 1, 2 is another window, and then 1, 2, 3. So these are all our windows, and then we say, okay, do any of these have duplicates? And the answer is no. The answer is no. So in terms of how to solve this algorithmically, so you could basically split problem into windows, and then for every window, check if duplicate exists. So that's one way to do it. There might be a more clever way to do it where you have basically, so when you go from one window to the next, you only remove this and add this, if that makes sense. So we'd remove this. So let's say we had a set. So our set would have 1, 2, 3. When we move to this, we'd remove one from the set and add one from the set. If when we add one to the set, there already is one in the set, then we know there's a duplicate. So for instance, with this problem, we would just add 1, 2, 3, 1. Yeah, so there's like, okay. So there's like initialize set, and then there's slide window. So, okay. So we'll say for I in range k plus 1. So we'll just have like current set, and then we'll say current set dot add nums of I. And then so in this case, the duplicate's within the first window, so we do want to check if if nums of I in current set, then return true for the whole problem. Otherwise, we'll just add it. So this is the initial set there. And then what we want to do is, so our window, we probably want to have, so we could say that now we'll have 2 pointers. So I equals, well, we only really need 1 pointer. But I don't want to optimize too quickly. So let's say I is 0 and j equals k plus 1, right? So that would be if k is 3, or no, I guess j would just equal k because we want to go 0, 1, 2, 3. So this would be our whole window. So then we're going to, while j is less than length of nums, we want to check so we'll remove first element, add last element, and then increment pointers. So okay, so we're going to remove the first element. So we'll say, I'm just thinking the order of how I should do this. So we have this. So then we want to remove this. So whatever I is, so we have I. So let's look at something like this. So we have I here, and j is, so should I put j to be here then? So right now my code has j here, but maybe I should have it here. And then, so it'll remove this, add this, increment. Remove this, add this, increment. Remove this, add this, increments. And then there's nothing left to add. Okay, that looks good. So I'm going to set it to k plus 1. So we'll remove the first element. So we'll say current set, and we know it's the first element is guaranteed to be in the set. So we'll say current set dot remove nums of I. Then we'll add the last element. So we'll just do this again. If nums of j in current set, then return true. Otherwise, just add it to the set, and then we'll say I plus equals 1, j plus equals 1. We could just do this for now. Okay. So what I want to do is, and then ideally, so then we would just return false at the end. So if everything works, so I'm just going to run it, and then, so all those comments are not needed here. Okay, so I'm just going to run it and see what output we get. I'm also going to print current set at every iteration, like that. So let's see how this looks. We're at 8 minutes. Okay, so that worked for those. Let's try submitting. Okay, so here we have an edge case where nums is equal to 1 and k is right, so k is being set to 2, so it's going to go 0, 1, and then when I equals 1, it will be out of range. So what does this edge case represent? It represents when k is bigger than, so I could say, so if k, let's think about this. So if k conceptually is bigger than, so if k is greater than or equal to the length of nums, and is that okay, k could be anything. So if k is greater than nums, then conceptually that means, like if k is infinity, then we basically just want to know if there's a duplicate at all. So that's where we could just do this. But we don't want an out of range error. So I think I could, maybe a clever thing to do would be k equals the minimum of itself and the length of nums minus 1. So we will, so if k is 4 in this case, that's the same as k really being 3. Anything greater than 3 in this example should just be 3 because it's the entire list. So now I'm just thinking, is it minimum? So if k is a billion, then yeah, it should be the minimum. Okay, so let's see if that fixes that test case, because now k will be equal to 0, right? Okay, output limit exceeded. But I feel like I didn't I get past that test case? No, okay. All right. So there we have a solution. Okay. I guess we could also check. I was going to say we could check the length of the set and make sure that it's equal to like basically the number of elements that we would expect. So it should be the difference in index. So I wonder why this is slow. So another kind of simple way to do it would just be like make a function called isUnique, which takes in like a list of elements. So like a group, I guess I could say window. And then we could say return if the length of the window equals length of set of window. So isUnique, yeah. And then what we would want to say is for I in range length of nums minus k plus 1 prints nums from I to I plus k. Let me just print this out quick. So I feel like this would be slower because so we have 1, 2, 3. Yeah, so let's do k plus 1. Is that going to give me an index error? So why is this 1, 2, 3? 1, 2, 3. So let's do k, just minus k. So we should generate one less window. Yeah, okay. So then we're going to check if not isUnique window. All right, instead of window, I guess we would say this. So we'll pass that. So if that's not unique, then let's return true. And then if we get to the end, return false. So this is a lot less code, but I feel like it's slower. Yeah, it seems to be a lot slower. Okay. Huh, okay, so it gave a wrong test case. I think it may be I didn't include the k thing. K equals minimum of itself in length of nums. Minus 1. Okay. So, I mean, it's taking a lot longer, so I'm guessing it will be slower. Because, so if we look at the O of n, so this is linear because we loop through. Yeah, so this one's a lot slower. So you can see it's way less code, but this part is O of n actually because we're converting it to a set. So this is n squared. So this solution is n squared. Because for every window, and we generate roughly n windows, we're converting it to a set, which is n as well. So this is the O of n squared solution. This solution over here is n, but it still looks slow. It may be because we're doing two loops here. So this is n, and then so looking up in a set is O of 1, and then this is also n. Well, it's sort of equivalent to one pass through. It's sort of equivalent to one pass through. I wonder if I could kind of mix the solutions and maybe just say, like, from I to K. Maybe we could say, like, first window equals I. I mean, so it equals nums of I until K. And then we could like set that. Or maybe we could say, so let me print first window. So hopefully it even compiles. Yeah, it doesn't. So that it didn't like that. Hold on, let me see that again. I is not defined. Okay, 1, 2, 3, 1. So it should be K plus 1 here. Because, oh yeah, because that one's not included. When you splice, the second index is not included. Okay, perfect. So then we could just say if length of first window does not equal length of set of first window, then return true. Okay. So this is basically just does the same thing as this. But this might actually be faster because, yeah, I think this should be faster because we like eject out of it earlier. I wonder if there's just like overhead with this in function. So that's 30%, and then this one is, well, I'm also printing that. So this is like 30-ish%. I want to see if it's a big difference or not. And this one is 19. Let me run it again just to be sure. Huh. Yeah, so to me, this seems like it would be faster because we can exit out earlier, whereas this we have to build the entire window no matter what. But it could just be that, because in theory, like this is O of 1, but there might just be some like overhead in the implementation. I'm not sure. But I guess I could leave it like this. So, and we don't really need a J variable either. And we don't need the 0 here. Yeah, I'll just leave it like this though. But yeah, okay. So that is my solution. Thank you guys for watching. I guess it's not really faster. Alright. Well, just from a readability perspective, I'm going to keep it consistent and do the same thing each time because it's not really that much faster anyway. So, yeah. So this will be my solution. So thank you guys for watching. Today was day 73. So I'll see everybody tomorrow for day 74.